In this video, we start with weighted mean. Marissa just completed her first semester in college. She earned an A in her 4-hour statistics class, a B in her 3-hour sociology course, an A in her 3-hour psychology course, a C in her 5-hour computer programming course, and an A in her 1-hour drama course. Determine Marissa's grade point average. The formula for weighted mean is X bar equals the sum of the weight times X divided by the sum of the weight. Remember, when you're calculating GPA, the weight is actually the number of credit hours being attempted. So our formula here is 4 times 4 plus 3 times 3 plus 4 times 3 plus 5 times 2 divided by, she's attempting 15 hours. Remember that a GPA is normally rounded to 2 decimal points, so her GPA would be 3.13. You also have to remember in this problem that an A is worth 4 quality points, a B is worth 3 quality points, C is worth 2 quality points, a D is worth 1 quality point, and an F is 0 quality points. The next question says heights of women have a mean of 63.6 inches and a standard deviation of 2.5 inches. And this is based on data from the National Health Survey. It says use the range rule of thumb to estimate the minimum and maximum usual heights of women. Then answer, in this context, is it unusual for a woman to be 6 feet tall? To use the range rule of thumb, remember that there's 2 parts. The formula for the minimum usual value is the mean, X bar, minus 2 standard deviations, 2S. The formula for the maximum usual value is the mean, X bar, plus 2 standard deviations, 2S. So our minimum usual value is 63.6 minus 2 times 2.5, which equals 58.6. The maximum usual value is our mean, 63.6, plus 2 times 2.5, which equals 68.6. Any height between 58.6 inches and 68.6 inches is considered usual for a woman. So if a woman is 6 feet tall, that means that she is 6 times 12, which is 72 inches tall. That would be unusual because that is not a height within 2 standard deviations. It's not within the minimum and maximum usual value. The third question still deals with heights of women. We have heights of women have a bell-shaped distribution. Use the empirical rule, and we have to find what is the approximate percentage of women between 61.1 inches and 66.1 inches. According to the empirical rule, we have that 68% of values fall within 1 standard deviation of the mean. That would be 63.6 minus 2.5, which is 61.1. And 63.6 plus 2.5 equals 66.1. Therefore, 68% of heights fall between 61.1 and 66.1 inches. Part B, what percentage falls between 56.1 inches and 71.1 inches? That's 99.7% of values, which fall within 3 standard deviations of the mean. Because 63.6 minus 3 times 2.5 equals 56.1, and 63.6 plus 3 times 2.5 equals 71.1. Therefore, 99.7% of heights fall between 56.1 and 71.1 inches. The next question says scores on a test have a mean of 70 and a standard deviation of 12. Michelle has a score of 94. We have to convert Michelle's score to a z-score. The formula for a z-score is z equals x minus x bar divided by s. In this case, z equals her test score, which is 94, minus our mean, 70, divided by our standard deviation of 12. So 94 minus 70 divided by 12 is 2. So she has a z-score of 2. Next, find the z-score corresponding to the given value and use the z-score to determine whether the value is unusual. Consider a z-score to be unusual if it's less than -2 or greater than +2. Also round your z-score to the nearest 10th place if need be. A body temperature of 99.8 degrees Fahrenheit, given that human body temperatures have a mean of 98.2 degrees Fahrenheit and a standard deviation of 0.62 degrees. Our z-score is 99.8 minus 98.2 divided by 0.62. Z equals 2.58, but if we round to the nearest 10th, that's one place past the decimal, z is equal to 2.6. That z-score is more than 2 standard deviations above the mean, so according to the range rule of thumb, it is unusual. Next, determine which score corresponds to the higher relative position. Which is better, a score of 82 on a test with a mean of 70 and a standard deviation of 8, or a score of 82 on a test with a mean of 75 and a standard deviation of 4. To compare the different test scores, we need to convert each test score to a z-score. So with the first test, z equals 82 minus 70 divided by 8. Our z-score is 1.5. For the second test, our z-score is 82 minus 75 divided by 4. Our z-score is 1.75. You want the higher z-score for a test score. That's the z-score of 1.75, which means that the test score of 82 is better. The next question deals with a box plot. So in order to do a box plot, we have to include the values of the 5-number summary in the graphs. We're given the weights in pounds of 30 newborn babies. They're listed below, and we are asked to construct a box plot for the data set. Our weights are 5.5, 5.7, 5.8, 5.9, 6.1, 6.1, 6.3, 6.4, 6.5, 6.6, 6.7, 6.7, 6.7, 6.9, 7, 7, 7, 7.1, 7.2, 7.2, 7.4, 7.5, 7.7, 7.7, 7.8, 8, 8.1, 8.1, 8.3, 8.7. Use Google Sheets or the graphics calculator to find the minimum, median, and maximum. We've already been doing that in class. The only thing new to find will be the quartiles. To find quartile 1, which is the 25% mark, you take the number of data values and you multiply by 0.25. In this problem we had 30 weights. 30 times 0.25 is 7.25. When you have a decimal number, you always round up to the next whole number, so we'll round up and use the 8th number. So we count over to the 8th number and we see that that is 6.4. That is quartile 1. To find quartile 3, that's the 75% mark, take the number of data values and multiply by 0.75. 30 times 0.75 is 22.5. Again, since we have a decimal number, round up to the next whole number, which is 23, we use the 23rd number. So if we count over to our 23rd number, that is 7.7, that is quartile 3. Remember, in order to do this, the numbers need to be in order from smallest to largest, which they were given in order in this problem. Now that we have the 5-number summary, we can pick the correct box plot. The correct graph is A. Problem number 8 is another box plot 5-number summary problem. This time we're given the test scores of 32 students are listed below. Construct a box plot for the data set. Our test scores are 32, 37, 41, 44, 46, 48, 53, 55, 57, 57, 59, 63, 65, 66, 68, 69, 70, 71, 74, 74, 75, 77, 78, 79, 81, 82, 83, 86, 89, 92, 95, and 99. Just like the previous problem, use Google Sheets or the calculator to find the minimum, median, and maximum. The only thing we'll actually need to find by hand is quartile 1 and quartile 3. To find quartile 1, again that's the 25% mark. Take the number of values and multiply by 0.25. We had 32 test scores times 0.25 equals 8. Now this time, since we have a whole number, you actually have to take the 8th number and the 9th number and find the average. The 8th number is 55, the 9th number is 57, so when we average those two numbers together, we get 56. This is quartile 1. Quartile 1 is 56. To find quartile 3, the 75% mark, take the number of data values and multiply by 0.75. So 32 times 0.75 equals 24. Again, since we have a whole number, take the 24th number and the 25th number and find the average. The 24th number is 79, the 25th number is 81, so when we average the two together, that equals 80. This is quartile 3. Quartile 3 is 80. Now that we have the 5-number summary, we can pick the correct box plot. The correct graph is B.